Calculus Essentials for AI Algorithms. Calculus might sound intimidating, but you don't need to be a mathematician to understand the basic ideas that make it so important for artificial intelligence and machine learning. Many of the most powerful AI algorithms rely on calculus to learn and improve. In this section, we will explore the core calculus concepts you need to grasp to work confidently with AI. Let's first see why calculus matters in AI. AI models, especially in machine learning and deep learning, work by adjusting parameters to minimize errors and make accurate predictions. Calculus provides the mathematical tools for measuring how changing one variable affects another, finding the minimum or maximum value of functions, that is called optimization, understanding how algorithms like gradient descent work to train models. Without calculus, modern machine learning techniques like neural networks would not be possible. Key concepts in calculus. Let's look at the essential calculus ideas relevant for AI. Functions. A function is a relationship between an input and an output. For example, f of x is equal to 2x plus 3. In artificial intelligence, functions often describe how model parameters produce predictions, the relationship between inputs and outputs in a neural network. Understanding how functions behave help us adjust models for better performance. Derivatives. A derivative measures how a function changes as its input changes. In simple terms, it tells us the slope or rate of change of function. For example, the derivative of f of x is equal to 2x is 2. This means for every unit increase in x, the output increases by 2. Why derivatives matter in AI? They help us determine how to change model parameters to reduce errors. They allow optimization algorithms to adjust weights in neural networks. Partial derivatives. In AI, we often deal with functions that have multiple inputs. Partial derivative measures how the function changes with respect to one input, keeping the other constant. For example, if we have a function f of xy is equal to 3x plus 2y, the partial derivatives with respect to x is 3 and with respect to y is 2. Partial derivatives are crucial in training machine learning models because they help calculate how each parameter affects the model's error. Gradient. A gradient is a vector of all the partial derivatives of a function. It points the direction of the greatest rate of increase of the function. In AI, the gradient is essential for determining how to adjust parameters to reduce errors, guiding optimization algorithms like gradient descent. Think of the gradient as a set of directions that tell you how to change each parameter to improve model performance. Gradient descent. Gradient descent is one of the most important algorithms in machine learning and deep learning. It uses calculus to minimize a function, often called the loss or cost function, which measures how far the model's predictions are from the actual results. The basic idea of gradient descent is start with initial values for model parameters, calculate the gradient, that is, how the error changes with respect to each parameter. Adjust the parameters in opposite direction of the gradient to reduce error. Repeat until the error is as low as possible. Gradient descent allows AI models, including neural networks, to learn by continuously improving their predictions. Practical example: loss function. In training AI models, we often use a loss function to measure how well the model is performing. For example, in a linear regression, loss is equal to n1I is equal to 1 summation of n in the bracket yi minus y raised to I close the bracket 2, where yi is the actual value, y raised to I is the predicted value. Using calculus, we calculate the derivatives of the loss function with respect to the model parameters and adjust them to minimize the loss. This process is at the heart of machine learning. While calculus can involve complex calculations, the most important takeaway for working in AI is this. Derivatives and gradients show how changes in model parameters affect predictions. Calculus helps algorithms to find the best parameters to reduce the errors and improve accuracy. Even if you don't calculate derivatives by hand, understanding these concepts help you follow AI models, learn and why certain techniques work. Practical relevance. In this course, you will see how calculus concepts are used to train machine learning and deep learning models, optimize functions to improve performance, understand how algorithms like backpropagation work in neural networks. We will revisit these ideas with practical examples and coding exercises to make them clear and usable in your AI projects. Calculus provides the mathematical language for how AI systems learn and improve. By mastering these essentials, you will gain a deeper understanding of how modern AI algorithms operate and how to work with them effectively. Let's continue building your mathematical foundation for AI.